Welcome to ETE MCQs. Let us solve a problem in digital circuits. It is about minimizing a Boolean circuit. The reduced circuit of the following original circuit is. So you have three inputs. The output is represented by F. Okay, so this is all we have. The three inputs are A, B and C. A, B and C are the three inputs. So these three inputs are given. The output is F. Now we can just notice that this is a OR gate. This is yet another OR gate 2, and this is an AND gate. And you have two inverters. When B is given as input to the inverter, the output is B bar. And C given as input to this inverter, it is C bar. So here we have A. A comes as input to this OR gate. And here it is C bar. In this case, it is B bar. Next it is C, and then it is A. Finally, it is A. So this is all we have. Okay. So what will we get at the output of this OR gate? Output of this OR gate is going to be the Boolean OR operation between A, B bar and C bar. A Boolean OR with B bar, and again Boolean OR with C bar. So this is what we get here. And at this interconnect, what we will have is B bar Boolean OR with C, and then Boolean OR with A. And these two are given as input to the AND gate. Okay. So the output F is nothing but the Boolean AND operation of these two terms. So we will have finally F is equal to A plus A Boolean OR with B bar Boolean OR with C bar, both of which are ANDed by the performed AND operation. This is performed Boolean AND with B bar Boolean OR C Boolean OR A. Okay, now let us perform based on the distributive property. This can be rewritten as A dot B bar plus C Boolean OR A, and then you have Boolean OR B bar with B bar Boolean OR C Boolean OR A, Boolean OR C bar Boolean AND with B bar Boolean OR C Boolean OR A. Now finally what we will get is A dot B bar Boolean OR A C Boolean OR A dot A is actually A dot A Boolean OR, here it is B bar dot B bar Boolean OR B bar C Boolean OR B bar A Boolean OR C bar B bar Boolean OR C bar dot C. This is 0. This becomes 0 plus C bar A. Now let us simplify this further and write all the terms that are associated with the literal A. We know that a Boolean variable in its actual or complemented form is a literal. In this case, A is a literal, B bar is a literal. Here A is a literal, C is a literal. A is a literal here, B bar is a literal. Likewise. So let me just write the terms that are associated with A. So I'll be having A B bar plus Boolean OR with AC Boolean OR A. I'm just looking for the next. Based on commutative property, this term can be rearranged. So this becomes A B bar and then finally Boolean OR with A C bar. So we are left with Boolean OR with, here it is B bar dot B bar is B bar Boolean OR with B bar C and then Boolean OR with, based on commutative property, C bar B bar can be rewritten as B bar C bar. I am just considering the product terms that has got a literal A. Okay, so you have got 5 terms here. 5 product terms has got the literal A and 3 product terms has got the literal B bar. Now based on distributive property, the above expression, this can be rewritten as A Boolean and with B bar based on distributive property, B bar plus Boolean OR with C, Boolean OR with 1, Boolean OR with B bar, Boolean OR with C bar. And here again, I'm just taking based on distributive property, I'm just rewriting it as B bar, Boolean AND with 1, Boolean OR C, Boolean OR with C bar based on law of union. We know that 1 plus x is equal to 1. This is based on law of union. So when I apply that, 1 plus any number of literals added, you perform Boolean addition with any number of literals, the result will be 1. That is what it means. So you have A dot 1 Boolean OR with B bar. Again it is 1 plus C bar is also 1. So this is 1 plus C bar is 1. So 1 plus 1 is again 1. So finally you have A plus B bar. This is your final expression for F. So the respective diagram can be drawn with A and B as input. You don't require a C, you just have A and B. A is taken directly to a OR gate, whereas B passes through an inverter. After inverter, it passes here, you have B bar, both of which are performed Boolean OR operation, and the result is F. So this is your final reduced circuit, digital circuit. So the final answer is D. It matches with D. So the solution for this problem is D. Thank you.